In this video, my goal is to try and go through these 7 trusses that I've listed here. I'll point out that for these ones, there are really good videos by a YouTube channel called Eureka Engineering. The guy who makes that channel also has published a textbook with a whole bunch of worked examples. I'd recommend it. The other ones, there are videos for this one. This 2020 is new, 2013 doesn't have a video. In all of my trusses, there are 2 methods that we can use to solve trusses. We can use method of sections and method of joints. There are videos that explain this, including HSC Engineering has videos explaining the concept. It's also described fairly well in the Copeland textbook. Most of the time we use method of sections. That is typically what we're going to do. What we're going to do is we're going to cut a line and we're going to take half of the truss. We're going to cut a line, imagining redrawing the truss, only one half of the truss, and we're going to look at the left or the right. Now, it doesn't matter which side we take, it's just one side will be easier than the other. Now, once we have done that, my students have, so most of the time we're going to use that. I think for this question we're going to try and use method of sections for all of them. There are other methods, but we're going to focus on method of section. Once we do that, we can use either there's 2 different methods within that. The meetup method, right, where we take moments about a specific location where the unknowns meet. The other method is called the lone wolf method. Again, just a name that my students have come up with, which I think is a useful way to refer to it. The lone wolf method is what this question is going to be, where only one member in the cut section can provide the necessary force to balance. So in this case, only one member has vertical forces, and we'll see that when we come to it. So I'll explain both of these when we come to them, but I want to use that terminology up front so that we know where we start. Okay, in this case, we're starting with a 2020 question, and the first thing is I've decided I'm going to take the right-hand side of this truss. When I've chosen where I'm going to put my section line, and I'm going to use the right-hand side. I'm going to redraw that, but in order to do that, it means that I have to find these reactions. So I have to find RA, and I have to find RB, which has 2 components, RB vertically and RB horizontally. Now, in another situation, we might have to join those together using Pythagoras' theorem, and we'd find the angle using the arctan. But for the moment, we don't really need that. We can just leave those forces as is. But I know that for my example, because I'm finding this side, I want to find these unknowns here before I get started. So to do that, I'm going to use moments, and so I'm going to specify this, that I always use clockwise as positive. When I was at high school, I used to use anti-clockwise mostly. At a certain point in my life, in uni and my professional life, I used a bit of both. But when I started teaching, I just decided I'm going to be consistent, and I'm always going to use clockwise as positive. So what I've said is the sum of the moments, so sigma for the sum of all the moments for m, and I'm measuring from this location A. All of my points are measured from that dot. And what I know is that all those moments are going to equal 0. It's a fundamental thing that we're aware that there's 3 things we're aware. We always know that the sum of the moments equals 0. The sum of the forces in the x direction, usually horizontal, is 0, and the sum of the forces in the y direction, usually vertical, is 0. If we know that, we can use that to solve this question, kind of like a simultaneous equation. Okay. So in this situation here, we have effectively 2 unknowns. We know what RBV is, and how we know RBV is because we say the sum of the forces horizontally have to be equal. So if this is 3, there's no other external force aside from this 3 here. So for that to be balanced, RBH has to equal 3. So I'm just going to rename that there, 3. Ordinarily I might not do that, but in this case that's going to work for me. So what I have is 2 unknowns now, and if I have 2 unknowns, that's a problem, but the magic of moments is that by measuring everything from 0, this is going to so measuring everything by A, this will multiply by 0. RA times 0 distance, because a moment equals force times distance, perpendicular distance, because I'm multiplying by 0, whenever I'm multiplying by 0, it's going to equal 0. So that means we can use that in our equation without messing things up, which leaves us this as our unknown. So, what I'm going to say is, okay, first of all, finding RA, we're measuring from A to find RB. So I'll start with all of my forces from RA. Now, I have a bit of a convention that I'll use a different colour when I'm saying you don't need to write this in your exam. So I'm going to write minus RA brackets 0. I always have a convention, I write force times distance. And then I go clockwise around that point so I don't lose anything. Then we write minus 1.2 times some amount of distance. Now, you'll notice that I've written minus, and the reason I write minus is because it's a whole lot easier to turn a minus into a plus than the other way around. So in this case, it's 0, right? RA, doesn't matter what it is, multiplies by 0. The value is going to be 0 no matter what. So 0 is neither positive nor negative. But I find that writing minus helps me into that mindset. Now this distance here, this is one triangle away. We're going to measure triangles, not meters. We're going to measure, with distances, it doesn't matter what our distance is. Because we divide everything by the distance out at the end, it doesn't matter if we use feet, inches, triangles, meters, cropogs, it doesn't matter. So we're just going to call that one triangle. Now the question is it going clockwise or anti-clockwise? Well, what I like to do is I like to put my finger on this dot and I like to spin it. So I go down, down, whoop, whoop. And that direction, that's an anti-clockwise movement. We've said clockwise is positive, so we've said this is negative following our convention. The next force here is 3. Now you might say 3 is a long way away, but actually that force continues all the way through, and its perpendicular distance, that was not a great bracket, is this distance here. 3, the closest it's ever going to get, the perpendicular distance, is that distance here. Now that's some amount of a triangle. How much of a triangle is it? Well, I'm going to save you the trigonometry and just tell you it's 0.866, what I call the disco number. Because we're assuming these are equilateral triangles, that means this is 60 degrees. And if I have a standard triangle, I'm going to draw this just here. If this is 100 and this is 60 degrees, that's 30 degrees, this will be 50% of that number, and this will be 86.6% of that number. Now, because of that, I'm going to have some amount of rounding errors in my equations, but I'm trying to do this quickly, so we're going to leave it at 0.866. Okay, so what is our force? So we're saying minus 3, and then our distance is 0.866. You can do the trigonometry. There's other videos where I'm sure they've gone through much more detail, but so we've said 3. Now the question is that 3 that I'm moving, I'm just transferring, because vectors can be transferred, is that 3 going clockwise or anti-clockwise around A? And the answer is anti-clockwise. So, I'm going to leave that there as a reminder, but so that stays as minus. The next force, as we keep going around, well, we're going to have this force here, which we've already identified, RBH, which we've called 3. So I'm going to write 3, but its distance, this force is actually, that 3 is actually happening up here. And because it's happening up here, its perpendicular distance is 0. Oh, I said I was only going to do that stuff in blue. Okay, I'll rewrite the ones that matter. Because I do this, I often go over the 2 lines. I apologize for that. 1 point. Okay. Minus 1.2 brackets 1 triangle minus 3 brackets 0.866 triangles, and then minus 0. Okay, and then we have finally our unknown. I'm just going to move that a little bit because I think I won't need a second one after all. Minus 3 brackets 0, and then I've got RBV, and its distance is 1 triangle, 2 triangles, 3 triangles away. Now, what I need to do is, I've just drawn this arrow as up. Now that makes sense, because I figure, well, there's some loads going down, so there's probably going to be, in order to hold this thing together, it's probably going to be an upwards force. But I don't know that. I made an assumption. So what I like to write here is, I like to write assume up, therefore, if it's going up, that's going to be, again, also anti-clockwise. Therefore, negative, right? So that's my assumption. So what I look at that is I say, well, there's this problem here because I've got a lot of negatives. Oh, okay, I've also got this one here. That one will help me out. Okay, and I am going to need 2 lines after all. So I have minus 20, and its distance is 1 triangle away. But is it minus? So I have my 20 here. The question is, and that should be in black, minus 20 times 1, and the question is, okay, is that clockwise or anti-clockwise? So if I put my finger on A and I spin around, it's going to be clockwise. So that's plus 20. So let's have a look at when we simplify that. What have we got? We've got 0 equals minus 1.2 minus 3 times 0.866 equals minus 2.598 minus 3RBV, and then plus 20. Okay, so if we take all these values, we're going to have 20 minus answer minus 1.2 equals, now I'm going to do, what I'm going to say, I'm not going to do this every time, I'm just going to start moving. I'm going to say, if I add 3RBV here, I then add 3RBV here. If you don't understand this level of algebra, then you maybe need to let your teacher know and do some work to catch up, because this is pretty much assumed algebra at this point. Okay, so that equals 16.2. Now, if I go to that, so if I know that I can buy 3 red balloons for 16 bucks, that means each red balloon is going to equal about 5 bucks. And that sounds about right. Now, here's the thing, our answer came up as positive. So we said positive, therefore our assumption was, write this up here actually, positive, therefore our assumption was okay, therefore up. And so we can write here, our answer is, all the answers here are in kilonewtons, and the kilonewtons up. So we've found RB. I'll write that here. RBV equals 5.4 kilonewtons up. Okay, I'm going to clear the board because I need that space. You know what, actually I'm going to give that a second just so that, make it fast. So I've decided I want to take this right hand side of the truss. So I'm going to redraw that now. Okay, and I'm putting all my forces back on here. 5.4, I've got 3, and that's it. Now, I've also cut, when I've drawn this section line, what I've done is I've cut and I've produced these 3 members. Now, I have a convention that I like to call the one that's named as C, and then the other ones I just call P and Q. I don't know why, but that's my thing. So what I'm saying is my target is C. That's the one I'm looking for. I'm going to put that in blue to show that that's the one we're looking for. And these ones here are my distractors. They're the ones I'm trying to ignore. Now, in this case, what I've done is I always draw the arrow assuming tension. Right? What I do is I just draw all of the arrows pulling out of the node. And by doing that, I assume tension. That's a pretty universal approach. It seems to be pretty commonly used. So when I look at these 3 unknowns, right, I have P is unknown, C is unknown, and Q is unknown. What I'm saying is that inside this member there's a force, and inside that force there's something that needs to be done to hold this shape in balance. The idea is if I was to cut this apart, what are the forces I need to apply to be able to hold this thing together? I'm not going to go too much more into the theory because I'm trying to work through this at speed. Okay. In this case, P and Q, they are both horizontal forces. They cannot deal with anything else other than horizontal forces. So the only way that we can resolve this is by looking at, well, we have this vertical force, something needs to be doing to deal with that. If I've got 5.4 up, somewhere there has to be 5.4 down. Now some students say, well, what about in here? Well, those are closed internal members. We haven't cut through those, they're not external members, and we haven't cut through that section. They don't appear in our section plane, whereas these ones do. And so the only one who can deal with this 5.4 is C. If C doesn't apply 5.4 down, the whole thing's not going to hold together. So we've got 5.4 up and we need 5.4 down. So the vertical component of C is going to have to equal 5.4. So how I probably should write that is I should write the sum of the forces vertically equals 0, setting positive as up. So I've got 0 equals 5.4 minus, because I'm assuming down, so if this is down, the convention would say that it should be negative because it's going down, CV. Therefore, CV equals 5.4 kilonewtons up. Now, I found CV, but that doesn't help me find the value of C. So what I'm going to do is I'm going to say, well, now this is not an equilibriant. This is a component force. So what I'm saying is if C, this is my guy C, this is CV, and this is CH, what are the forces that need to make this work? Well, I'm saying that if CV equals 5.4 down, well then how much is C going to need to be? Well, we said this is 60%. We said, well, in the same way that we have this triangle up here, this is 84%. CV equals 80, sorry, I said 84, but it's actually 86.6% times C. Therefore, C is going to equal, we've got to divide by both sides. So we're going to get C 5.4. 5.4 divided by 0.866 equals 6. I'm going to write that as 0 just so that I don't have to do it as a percentage. Equals 6.23 kilonewtons. Now, I said here that this value for C is down. Let's see if that matches. I said here that it was down, and they do match. And because they match, I said here that I was assuming tension. And if I was assuming tension and this and that match, we can then say C equals this in tension. Okay, I'm just going to quickly check my answers because, you know, if I'm going to be wrong, I'd rather be wrong early. Okay. C equals 6.23 kilonewtons, yeah, and it is in tension. Okay, we're done. First one is done. So, I'm going to put a line through this, and okay, in this question, oh, get rid of this. In this question, I'm asked to find N and M. I don't really like that it's called M because M is used for moment, N is also used for axial load, but we won't worry about that. Now, what it's asked, I'm just going to tell you that it's asked us to find that. Now, the first thing we want to do is we want to think, well, where are we going to place our cuts? Now, going alphabetically, let's say we're going to go for M first. So, I look at M, and I see that it's here. Now, when I'm deciding where to put my cuts, I mean, I could do something crazy like this. But if I did that, I would have this many unknowns. FD is unknown, GD is unknown, DE is unknown, BE, which we're calling M, is unknown, BC is unknown, AC is unknown. That's a lot of unknowns. 1, 2, 3, 4, 5, 6. 6 unknowns, a lot of unknowns. Don't want that. So what are we going to do instead? Well, I just look and I see straight away, that gives me 1, 2, 3 unknowns. Now the question is, where do I want to go for my forces? So with my forces, I want to think, well, which side looks simpler? Well, if I go up here, everything's kind of, if I go the top half, I don't need to worry about these reactions at all. And that looks good because that means I don't have to do as much work. So I'm going to choose the top half of my cut. So I'm going to draw that to just a little diagram here that sort of represents that. Okay, now what are my forces? I have 3, and I have 12, and I have 7.5, and then I have my 3 members that have been cut. Now, normally I'd call this P and Q, but they've actually given these names, so we'll go with BD and M, which I don't like, but we're going to call it that, and EC. Okay, so the question is here, I have my target, M, and I have my two unknowns, the two that I need to eliminate. I can't have this many unknowns. I can't do an equation with that many unknowns. So what I'm going to do is I'm going to look at the location and I'm going to say, well, where does B and EC meet? Well, what I do is I just draw that line out, and then I draw this line out, and I say, well, they both meet here at this location H. So I can start. I can say, well, okay, sum of the moments, I always establish clockwise, sigma for sum of the moments measured from location H equals 0. Now there's 0 everywhere, but we've chosen H because that eliminates these two. And to get started, I'll write 0 equals, and I'll just eliminate those two. And now you don't need to write this, and I'm writing that in blue. But I'm going to write BD brackets 0 because it's eliminated. And I've got EC brackets 0 again because it passes. This force passes through H, and this one passes through H. So I also have 3 times 0, because that passes through H. Now the question is, this question will get more difficult from here. So when I'm looking at this one, well, okay, it's 12 meters, and even if it's not established as being symmetric, we can make a reasonable assumption of saying that this is going to be 2, and that this one here is going to be 4. Pretty reasonable assumption. Okay, so I'm going to say that we're using black because we're working with stuff that we would need to show now. This is necessary working. Now, up until now, you could get away with just writing the right answer in the HSC. That has changed. The advice that we've been given is that you must show reasonable working out. If you don't show reasonable working out, if you don't demonstrate your answers, you will get 0. Now, I actually totally supported this answer, this opinion, because in the working world, you will have to have your calculations your boss will check, his boss will check, and then another boss, an independent verifier somewhere else, she might check. So you've got to know that people need to be able to read your working out. Okay. Now, I've written plus there. I've jumped the gun. I've written plus, and that's because we're saying, well, from point H, this 12 is going down. And when it's going down, that's going to go clockwise. It's a clockwise movement. So I've written that as plus, because we've said as clockwise as positive. I've now got this one here, 7 kilonewtons, and this 7 kilonewtons is going anti-clockwise. Now you might say, well, it's all the way down here, but if we remember the force is transferable, so we can just move that line up, it's going anti-clockwise. Okay, so we've got 7 negative, and it's 4 away. Now the last part, this is the one that's the real stinker, right? Is this M. How do we get rid of M? Well, you might say, well, what's the problem? The problem is that we don't know the perpendicular distance of M. So what I'm going to do here is I'm going to draw this distance, and then I'm going to draw that. Now you'll notice here that is on this question it says not to scale. Now I haven't looked at, I think in class we discussed this, and I can't say this with 100% certainty, I can say with 99% confidence that none of the other questions that we're going to look at today would ever say not to scale. And look, I would never tell you to ignore something that said not to scale in professional life, but in the HSC, if I was in a panic and I didn't have the geometry to figure this out, I would just be ignoring that and I would just be doing it to scale. Let's see how I would actually do that and see how quickly I can. Now, for me, I'm going to call this distance, D, right, lowercase d. And I'm going to try and find that distance, the distance from here to here. Okay. Briefly, what I'm going to say is, well, I know the distance. If I look at this triangle, I'm going to redraw this triangle. I've got a triangle that looks like this, and then a triangle that looks like that. And this triangle here is 6, and this one here is 3 times 6, which is 18. And then what I'm going to try, I know that those angles, those are that.
Oh, yeah, I ran out of paper and you printed.
Okay, so I've got. To find this one here, I've got 6 squared is 36 plus 18 squared. I can't do it in my head. I probably should be able to. I'm going to take the square root of all of that. It gives me 18.97. Okay, and then I have been given this angle which they've told me is 40.6. So I will have to do trigonometry now. So I've said this is D. So what I'm going to say is, if this is D, then, okay, so I've got my hypotenuse, and I'm finding the opposite. So SOH, TOA, this will be probably the only time I go through this. So if we're using sine theta equals opposite over hypotenuse, so I'm trying to find the opposite, so I can rewrite that as hypotenuse times sine theta equals the opposite. And so what I can now say is, well, 18.97 sine 40.6 equals D. D equals that number, sine. Now, a thing that I encourage my students to do all the time is to think, does this number make sense? The answer I've got is 12.34. Now, I'm pretty sure that's right from memory, but it's important to think about, well, this is the hypotenuse. Is the number, if the number was 30, it would be wrong. If the number was 20, it would be wrong, because the hypotenuse has to be the bigger side. If the number was 6, well, just looking, at my eyeballs, it just seems that's wrong. So that helps me to think, okay, an estimation is really it's a critical skill. Okay, so what I'm going to say here is I've got then brackets M, brackets D, and I'll write in the answer there. I'll rewrite that as 12.34. Okay, I'm trying to stay in the white space. Okay, so let's rewrite that. 0 equals 24 minus 7, it's 28, minus 12.34 m. Okay, if I add 12.34 to both sides, it looks like this. 12.34 m equals, okay, so I've now got 24 minus 28. Let's just check that I've done that right. 12 times 2, 7, okay. I've got minus, okay. I have to explain how I wrote. Let me just check this here. I may have made a mistake. I got so excited about writing m that I just wrote minus here without thinking about it. Let's have a look at m. I've drawn this as an arrow pulling out of the node, right? That's a convention. We just draw arrows pulling out of each of the nodes. And if that's the case, it's going to be going clockwise. So that should really have been a plus, that should be in black, plus, and that's a minus. Okay, now I'm feeling better about things. 24 minus 8 gives me minus 4. So those minuses both cancel. And that tells me that m, well, if I could buy 12 M&Ms for $4, how much would each M&M cost? Well, it'd be about 30 cents each, right? That seems about right. Let's have a look. M equals 4 divided by 12.34. Okay, 4 divided by that answer equals, m equals 0.323. Now, the forces are all given in kilonewtons. Now, we said here that that number became a positive number, so I should write up the top here. We assumed tension, therefore clockwise. Now here we can say our assumption was okay, therefore tension. We know it was okay because our answer was positive. If we got a negative answer, that would have told us that something was wrong. Okay. Now, the next thing we need to do in this question is, look, I'll just check before I go on. I don't want to lose the thread too much. Yep, that's right. They round. My rounding may be a little bit off. Okay, the next one here is a little bit more difficult. Not difficult, it's actually easier in a lot of ways. This finding D was pretty hard, right? That's why this is a 6-mark question. The next question though, what we need to do is we need to find out what n is. And with n, that's a really different method of sections. So if I draw my section line, effectively what I get is a method of joints. If I cut here, I cut through n, I'm going to redraw that diagram here. I have this and this. I have whatever the reaction is, and then I have N, and then I have this force. Now, straight away, when I look at this force, what I'm going to call this is AC. When I look at AC, what I can see, what I can tell straight away with AC is that if AC has any amount, let's assume it's going to the left. If AC had any amount of leftness, it would bust out of the force, because Ricky the roller, the A is a roller, so it can only have up. It can't have left or right. So if AC has any amount of left, there's nothing pushing back to stop it from going the other direction. So AC has to be equal to 0. So we call that as a zero force member. AC equals 0, zero force member, and we've just done that by inspection. So what that means is we know that then, from sum of the forces vertically, that N equals to AC. Right, they're going to be equal and opposite. So the question is, we then have to find AC. Now, look, ordinarily I would just say, I'm too lazy, but I guess we'll keep going. To find RA, we need to take some of the moments about, I guess I can clear this space up here. Okay, we're going to take some of the moments about C equal to 0. So measuring from C, let's find all the forces. Okay, there's RC, 0 equals RC bracket 0. You don't need to write that. What do we need to write? Okay, we have RA. Now I'm making an assumption that RA is going up. If RA is going up, it's going to be clockwise. RA up, and its distance is 12 meters away. Okay, I can write the bit about assume up. Okay. The next force is I've got 7 down, minus 7. What's its distance? Its distance is 10 away. It's going anti-clockwise relative to C. The next one is 3. It is also going anti-clockwise, and it's 18 away. The next force is 12, and the 12 is 4 away, and it's also anti-clockwise. So with all of those things, what are we left with? Okay, so we're going to say 0 equals 12 RA minus 70 minus 3 times 18, 54 minus 48. Well, okay, if I have minus 70 minus 54 minus 48, I'm going to get minus, so I'm going to say, I'm going to bring this to both sides. I'm going to say minus 12 RA, I've moved that over to the other side, is going to equal minus 172. So if I could buy 12 rabbits for 170 bucks, well, each rabbit's going to be more than $10. So RA is going to equal, divided by 12 equals $14 per rabbit. Now, our answer was positive. These two net minuses cancelled, so therefore we can say positive, therefore our assumption was okay, therefore up. And that's how we know that it's up. It's possible, there are situations where if the force had been going the other way, if we'd had 30, let's say I put a force of 300 there, in that case it would be down in order for it to stop falling over, but it wasn't the case, so we're going to move on. Okay, so we've now got RA, therefore N equals 14.3. Now, what we're saying is that in order for, if RA is going up, that means N has to be going down. Now, if it's going down, it's going into the node, right? And that symbol there is compression. I know it doesn't look like compression, I know it's not intuitive, I have a whole song about how it's not intuitive, my Hey There Delilah song, but it is compression. Okay, so that's this question. We are done with the second one. I will get the other answer up. So that's the answers that the other student, the other teacher, so this is Aiden G. His channel, he'd come up with those same answers. I had that to help me check if I was being right. Okay. Those two questions were both 6-mark questions, easily, substantially harder than other questions we've done. Now, I might at some point, because I'm just conscious of time, I might cheat on some of the reactions, but we'll see how we go. Really should have done the other side first, but then it's going to make much difference. Okay. A pin-jointed truss is shown. Okay, I can tell us that we're going to find C, is what we're finding here. Now, the question, actually I'm sure probably asked us to find the reaction. I'm not interested in that part, I'm only interested in the truss component. So they've asked us to find C, which I said I would draw in blue. They're asking us to find C. And straight away, well, I just think, okay, I'm going to draw a cut through there. That's a section line. When I draw my section, well, I'm going to choose the right-hand side with all this unknown, or I'm going to choose the left-hand side. That's a pretty easy choice. So, I then draw arrows out of each point, and I'm going to call this one P and this one Q as my convention. And I've got 3, and I've got 20. Oh, I'm liking this question. Okay. Now, here's the problem. I'm finding, oh, sorry, this is Q and this is C. I'm finding this guy C, which I said I'd put in blue. I'm finding C. How do I eliminate P and Q? Well, let's have a look. The first thing I'd say is just draw out the line. And if I do that, I identify that these two meet. Now my convention is to call that, I call it Z, right, or X, but Z's probably good. Excuse me. Okay, so what we're going to do is we're going to go over here and we're going to write sum of the moments. The sum of the moments at every location are equal to 0, but we're measuring from Z, so we can eliminate 2 unknowns. To eliminate those 2 unknowns, I'm going to write them in blue. You don't need to write this in blue. The blue part is not important. Okay, I've got P brackets 0, because it's 0 perpendicular distance from P. We're calling this the meetup method. It's meeting up at Z. I've got Q, also at 0. I've written minus there because I don't know that it's times 0. 0 has no positive on i's. Okay, so I'm now up to C, and I'm looking at, does C go clockwise or anti-clockwise? C goes anti-clockwise, so I'm going to write minus C. And what is the distance from C? Well, given this shape, they haven't said it's not to scale, we're going to say it's 1.